Ever wondered if we're alone in the universe? The James Webb Space Telescope is revolutionizing our search for alien life. With its massive golden eye and incredible tech, it's peering deeper into space than ever before, hunting for signs of life on distant worlds. Let me tell you about Webb's most amazing feature, its massive golden mirror. Imagine trying to fit a 6.5-meter mirror into a rocket that's only 5 meters wide. Sounds impossible, right? Well, NASA pulled off some serious engineering magic here. The mirror is actually made up of 18 hexagonal segments that fold up like the world's most expensive piece of origami. During launch, it was all tucked away like a butterfly in its cocoon. But once in space, these segments slowly unfolded in a cosmic dance that had everyone at NASA holding their breath. Each segment is coated in a super thin layer of gold. We're talking about 48.25 grams, or about as much gold as you'd find in a class ring. This golden coating helps Webb catch even the faintest light from the most distant stars. Here's where Webb really shows off its superpowers. While Hubble mostly looks at visible light, the kind our eyes can see, Webb is all about infrared. Think of it like this. Visible light from super-distant galaxies gets stretched out during its billion-year journey through space, kind of like cosmic silly putty. By the time it reaches us, it's stretched into infrared. That's why Hubble might miss these far-off objects, but Webb catches them like a champ. Plus, infrared light cuts through cosmic dust clouds like a hot knife through butter. This means Webb can peek right through those pesky space clouds to spot baby planets forming around distant stars or catch the heat signature of an alien atmosphere. It's like Webb has cosmic night vision goggles. Let's talk about nature's cosmic autographs, biosignatures. These are the chemical clues that scream, "Hey, something's alive here." Think of them as space detective work. When Webb analyzes an alien planet's atmosphere, it's looking for specific molecules that usually come from living things. On Earth, plants pump out oxygen and bacteria produce methane. These are classic biosignatures. But here's the cool part. If Webb spots certain combinations of gases that shouldn't naturally exist together, like oxygen and methane, that's a huge red flag for life. It's like catching the universe's most exciting chemical fingerprint. And Webb's infrared superpowers make it perfect for sniffing out these telltale signs in alien atmospheres. Let me introduce you to the coolest planetary system we've ever found, TRAPPIST-1. Just 39 light-years away, there's a tiny star with 7 Earth-sized planets huddled around it. These planets are so close together that if you were standing on one, you'd see the others looming huge in the sky, like giant moons. 3 of these worlds sit in the Goldilocks zone. Not too hot, not too cold, just right for liquid water. Webb is taking a super close look at their atmospheres right now. It's like having a cosmic chemist analyzing the air on each planet, searching for any hints of life. The data's already rolling in, and astronomers are practically bouncing off the walls with excitement. Ready for some mind-bending space science? When Webb catches light from an alien planet, it plays an amazing trick. It splits that light into a rainbow spectrum like a cosmic prism. But this isn't just for show. Each chemical in that planet's atmosphere leaves its own unique pattern in the light, like a fingerprint. Think of it as a barcode scanner for alien atmospheres. When starlight passes through a planet's atmosphere, certain wavelengths get absorbed by different molecules. Water vapor might gobble up some infrared light, while methane snacks on others. Webb reads these light patterns like a cosmic recipe book, telling us exactly what's cooking in that alien air. And with its super-sensitive instruments, it can detect even tiny traces of interesting chemicals. That's how we might just stumble upon the signature of life. Let's get weird for a minute and talk about what alien life might actually look like. Forget little green men. We're talking about possibilities that would make sci-fi writers' heads spin. Maybe there's a planet where tiny space algae float in purple oceans, turning their star's light into energy just like Earth's plants do, but with totally different chemistry. Or what about creatures that breathe methane instead of oxygen? It sounds crazy, but on a super cold world like Saturn's moon Titan, that might make perfect sense. Webb could spot signs of these otherworldly life forms by catching unusual patterns in their planet's atmosphere. The coolest part? Life might be using chemical tricks we haven't even thought of yet. Grab your coffee and hold on to your telescope because Webb's latest findings are absolutely wild. Remember that boring galaxy we thought was empty? Webb just showed us it's bursting with thousands of never-before-seen stars. But that's just the warm-up act. Webb caught something really bizarre in the TRAPPIST-1 system, weird chemical signatures that don't match any of our computer models. And get this, we spotted water vapor in the atmosphere of a planet that's kind of like Earth's bigger, steamier cousin. Scientists literally started texting each other at 3 a.m. when that data came in. The telescope also snapped a photo of the oldest galaxy we've ever seen, from when the universe was basically a cosmic toddler. We're talking about light that's been traveling for over 13 billion years. You might think spotting alien life would be straightforward. Just find some oxygen or methane and boom, we've got aliens. But hold your horses, space fans. The universe loves playing tricks on us. Take Venus. Back in 2020, scientists thought they'd found phosphine, a possible sign of life, in its clouds. Everyone freaked out. But after double and triple checking the data, that signal started looking shakier than a satellite in a solar storm. Here's the thing. Lots of non-living processes can create the same chemicals we associate with life. Volcanoes burp out methane, stars cook up oxygen, and space rocks can bring all sorts of funky chemistry to a planet. That's why Webb's team has to be like cosmic detectives, ruling out every natural explanation before they can even whisper the L word. Want to know what's next for our favorite space telescope? Webb's got a packed schedule that'll make your head spin. Over the next 5 years, it's going to check out over 50 potentially habitable planets. Each one could be the jackpot in our cosmic lottery. The really exciting part: Webb will take an ultra-close look at some newly discovered systems that Hubble can't even see. Scientists have already booked time to study mysterious planets that seem to rain molten iron. Yes, really. And others that might have global oceans. There's even a plan to watch planets being born in real time. And here's a wild thought. If we do spot something unusual, Webb can go back for a second look within just a few weeks. The next 5 years could completely change what we know about our cosmic neighborhood. Let's talk about the elephant in the cosmos. What happens if Webb actually finds signs of alien life? It would be the biggest plot twist in human history. Suddenly, we'd know we're not alone in this vast cosmic ocean. Scientists would be popping champagne bottles while philosophers have existential meltdowns. Would these aliens be microscopic pond scum or super-advanced civilizations? Either way, it would force us to rethink everything: our place in the universe, our religions, even our own future as a species. But here's the really mind-bending part. Finding simple alien life would actually suggest that the universe is teeming with it. Because if it happened twice, just in our cosmic backyard, imagine what's happening in those billions of other galaxies. Thanks for joining me on this cosmic journey through Webb's alien hunting adventures. If you enjoyed this space exploration, smash that like button, hit subscribe, and share with your space-loving friends. Let's keep searching the stars together.